episode of creating a Swift-based, NIO framework-based multi-user dungeon game. Last time where we left off, we created an echo server that colored text that was sent back to us. Today we're going to work on creating the actual pipeline for the MUD game, and that's more or less also the most important part of all the NIO specific stuff we're doing. So basically at the end of this episode we have more or less the engine for our game available. We will add stuff to it later on, no worries, but the basics, or at least the happy flow, will be there. So where did we left off? Well, we have our main.swift file, and we have in a pipeline with two handlers, and today we're going to increase the pipeline, or redefine the pipeline as follows. Our pipeline will be this. We will have our back pressure handler to make sure we're not overflowing our system, and from there we'll be going to a session handler, and the session handler will be responsible for associating the incoming messages with the player sessions, because the byte buffers themselves don't have that information, so we need to store that information somewhere and make it available also for the next handlers, because you need to know which session you're working in and which players are associated with those. So we have our session handler. What we then will do is we'll send it to a handler that will transform the command or the text the player typed. It will try and transform it into a command, something that our game engine will be able to understand. So if somebody types get lamp, the verb handler will slice that up into a verb get with a noun called lamp, and give that data to the next one. So the verb handler itself will not process or interpret the command itself, but it will at least try to make a structured command from it, and our parse handler will be responsible for receiving that command and then executing the command. And the parse handler will send back a response, and our response handler will send it back to our client. So if we're looking at what's coming out of this one will send out a byte buffer. The session handler will send out something which we call a text command. So we're just using basic text here. The verb handler will send out a verb command, so we know a bit more already. The parse handler will send out a MUD response, and our response handler will send out again a byte buffer, because that's what will be sent back to the telnet client. So we're back where we started. So this will be our pipeline, and we'll spend this session setting up these handlers, and we'll most likely use a few as a sort of stub at first. I want to spend most time on the verb handler, the parse handler, and the response handler. But let's start with the first one that we need. That's our session handler. And that one doesn't exist yet, so we'll create a new file, a new Swift file called session handler. And again, this will be using NIO, and of course I'm lazy, so I'll copy paste this one and make the changes as required. So we have a byte buffer going in, and we want to have a text command going out. And what's a text command? Well, we'll create a struct called text command, and this will contain two things. It will contain a session, and it contains a command, a string. And this And the session is what we will use to associate channels, the incoming requests to players. So a session will have a couple of, will require, let's say, an ID, and it will require, it might already have a player ID, because the player might not be logged in yet, and it will have a channel, and this is a NIO channel, and this way we can associate these two with each other. So this is our text command. Our echo, this will be our session handler, and what we're getting in is the we're still getting in the data as a byte buffer, and we can still change it to a string. And now we need to do something to create a session out of it. At first, let's not worry too much about sessions and players and so on. Let's just say we have a session. This will be a throwaway thingy. So we'll just create one. We'll add a channel and won't have a player ID yet. And for the out buffer, we will be, let's see. So we have a session. We need to transform it into a command. Let's see, so we have a session. Let's create a command. It will be a text command, and the session will be the session, and the command will still be simply our string that we received in. So we don't yet know exactly what the string means. We just know we received some data and we associate it with a session. And what we're going to do is we're not going to write it out. We're going to send it to the next handler, and we're going to do that using the fire channel read. This will call the channel read function in the next handler, and we're going to wrap the inbound out data the command. So now we're sending out a command from here to the next handler, which we haven't created yet. So let's see. So we have a session handler. The next one will be our verb handler. And it's easiest to just copy paste the last one because they are quite similar. So we have a verb handler, and let's take this one because it will be quite similar. Import NIO. This one receives a text command and will send out a verb command. Now, what's a verb command? It will be another structure, and it will have a session, and it will have a verb, which will be a data type we haven't defined yet. The reason we're again including the session is because we need to associate. The session knows the channel that the player is working on, as well as the player ID if the player has already logged in. And that way, if we keep passing it around, we always know which player we're working on and which session we're working on, because these session handlers, or these handlers themselves, are more or less stateless. So they don't know exactly what happened in request player sent before, or which they just know what's coming in and what's going out. They're sort of like pure functions in that sense. So we need a verb. Let's create a new Swift file, and we'll call it verb.swift. And a verb will be an enum. And the first case we'll add is the close command, because this one is really simple to set up. Now we need to make sure that we're able to translate the texts that people type into the commands. What we will also do is we'll make a case for illegal if somebody types something that is not recognized as a word, as a known word or a known command. And we will create make a helper method that creates these verbs. So we'll create a static function, create a verb from a string, and it will send back a verb. And what we're going to do is we're going to take the string, and we're going to string it. By trimming the characters in the white spaces and new lines. This way that if there are spaces before or after the new lines and so on, they get trimmed from the string. This makes processing a lot simpler. Next, what we're going to do is we're going to split the string into parts. So we take our trimmed string, we're going to split it at space. So if there are multiple words, then we get multiple parts. And then what we're going to do is we're going to do a switch. Now first we're going to check whether the string is empty. So if parts.count is smaller than 1, so if like there's nothing, or if the part 0, the first part, is an empty string, then we'll return empty. We might even be nicer to use a guard statement here, so we'll make sure that it's at least 1 part long and it's not empty. So then we get an empty string bank. Then we'll try and switch on the first part, and what we're going to do that uppercase, so we can make sure that even if players type lowercase, uppercase, letters, mixes, we'll always check for uppercase, and we'll check for the case close. And if this one works, then we simply send back close. If for some reason we get something else, we'll assume we have an illegal verb. So, and that's going to be a let because we're not changing it anywhere. So this should be enough for the for a verb so far, and it means we can start using our verb handler. So what we're getting in is we get in our text command, and And we'll have our verb be a verb create verb from a text command dot command, because that's the text. And then we can create a verb command using the session that we got from the text command and the verb we just constructed. And then we just send out the verb command. And this will be our verb handler. I'm doing a quick build to see if there are any syntax errors, but it seems not. Okay, so we have our verb handler. Let's see, 2 down, 2 to go. Then we have our parse handler. So we'll create a new file. Parse handler. We'll take this one as the basis. So again, we need NIO. We're getting, we receive a verb command, and what we're going to send out is a MUD response. And that's something we also need to define. So we'll create a struct MUD response. And that's simply the session and a message. And the message will be a string. And this is what the player will eventually see. So we have a channel read, we get a verb command. And for now, let's keep it as simple as possible. We'll switch on the verb command dot verb. And we'll say, well, if it's close, we'll also have a response. We'll say response is MUD response for the verb command dot session, and a message will be goodbye. We'll make sure we'll also handle the legal case. Just print out an error message, and we'll also handle the empties, the case of the empty string. Just send a new line, and finally we'll have a default and we'll say that we still have a verb command session. We'll just say that a command is not implemented yet. Something like this. The switch should now at least be extensive, and we now have our MUD response, so we can send out a response. Typo. This should also now be happy. Sure that this is just catch all. Final one. We have a parse handler, and now we need our response handler. So yet again, new file. And I will reuse the echo handler for a bit here, because we can use the echo, this logic to help. Important. Class response handler inbound, channel inbound handler. when we get a MUD response in, we send out a byte buffer. So we get our response. And all we're going to do is we're going to we're going to do a few things. We will take the response. What we will also do is we will color it, and then we'll send a new line and then a prompt. So player understands that they can now start typing another command. So we need to create a buffer for this for the string. Oh, response, and then it's just let's see, response dot command. What did we call it again? Message. Okay. We take the response in the message. This should now be okay. So we have the green string. We create a buffer for the string. We write it out, and then we flush it. And we should now have something that's sort of working. So we have server. So I type foo, but it's not a well-formed sentence, and so we can no longer, instead of the last time, we can no longer just echo back. However, we can send an empty line, and we get back an empty message. We can also send a close command and it says goodbye, but it's not closing yet. So that's something I do want to add. And for now, we will do it a bit easy. The session will have a variable should close, and by default it should be false. And in our parse handler, we should have our updated session. We can now also use updated session here, which feels a bit nicer. And for close, we can now say update session should close is true, and this will now be sent here further down the chain. Let's see, and then we have our response handler. What we can do here is if response.session should close, context close. And this should now allow us also to delete the session. We can print out closing session something like this. So we connect, we say close, and it says goodbye, and then connection closed for 4 and house. Cool. Okay, I think that's it for so far. So we're going to do a few improvements going forward. I think the first one that we need to tackle is being able to handle players logging in and logging out, or at least creating a player and then logging in. And that requires a bit of work because it requires maintaining a list of all sessions. It means we need to define users and define additional verbs for creation of players and logging in. And finally, you need to add the logic that actually logs a player in. But that's something for next time. So thank you for watching. Have a good day. Bye bye.